Just like we conducted tests around the population mean, we can also conduct tests around the population proportion. The way we construct the hypothesis is very similar. If we have a conjecture we are verifying, we give that belief the benefit of doubt, and we cast our null consistent with that conjecture, and the alternative becomes the opposite. If it's a research finding that we are investigating, we will set up the conclusion we hope to find as our alternative and the opposite as the null. Regardless of the procedure, we will still get three types of tests. We can get the left tail test, we can get the right tail test, or we can also get the two tail test. And these depend on the arrow of the alternative. If our alternative is pointing to the left, we get the left tail test. If the arrow points to the right, we get the right tail test. And the third case is the two tail test. In terms of setting up the test statistic, because we are making a claim about the population proportion, we will use that as our population proportion value. So to construct the standard error of the population proportion, we can use our P naught or our hypothesized proportion value in the standard error calculation. So our standard error of proportion is the square root of P naught times 1 minus P naught divided by n. And this is our standard error of the proportion. The next question to ask is, what is the statistical distribution of a test statistic? And there's a condition that we can check for if our sample size n times our postulated proportion of the population, not our sample, but the postulated population proportion is more than 5. And if our n times p naught times 1 minus p naught, which is our probability of failure, is also more than or equal to 5, then the test statistic z follows a standard normal distribution. So we can use the z-tables or the z-stat to look at the p-values once we obtain the test statistic. And also notice here that even though we have p-bar, which is from the sample, and we do not know the population proportions variance or the standard error of population proportion, the fact that we are working with a postulated value p naught, whether it's a two-tail test or a right tail test or a left tail test, because we know p naught, we can make use of p naught in calculating the standard error of the population proportion. So the standard error is p naught 1 minus p naught divided by n. So just make sure that we're not using p bar, but the p naught when we calculate the standard error. And the test statistic that we obtain will follow a z distribution. And that helps us then evaluate the p-values. So let's apply this to an example. Let's say that we know that the population proportion of union membership in 2018 is 10.2%. So this is our P naught. And a survey was done in 2023 of 400 US workers to determine whether union membership has increased over time or not. So part A says formulate the hypothesis that can be used to determine whether the union membership increased in 2023 or not. So this is the finding we hope to conclude. This is a research finding, so we will formulate that as an alternative. So in terms of the setup, our null would be that our union membership is less than or equal to 0.102. So it has not gone up. Our alternative is that our union membership has gone up over time and it's more than 0.102. So part B then says, we are given that 47 workers out of our survey of 400 workers belong to the membership. We want to conduct our hypothesis that we constructed here. So we will first find our sample proportion. It is given by our success over our sample size. Our success was 47 and our sample size is 400. And this gives us 0.1175. So this is our sample proportion. Let us also check for whether our sample size conditions to use the distribution are met. and that is given by our n times p naught, which is 400 times 0.102, and that equals 40.8. So that's more than 5. And then our n times p naught times 1 minus p naught is 400 times 0.102 times 0.898, and that equals 36.6. That's also more than 5. So we can use the z distribution in this case to test our hypotheses. So the next step involves formulating our test statistic, which is z, because it meets our conditions for being able to use the z distribution. Our sample proportion minus our postulated value divided by the standard error of the population proportion. So let's calculate the standard error of the population proportion, which we said is given by our p naught, 1 minus p naught divided by n, which is 0.102 times 0.898 divided by 400, and the square root of that. And this is given, this will be equal to 0.015. So putting this all together, our test statistic, or our z-stat, is our sample proportion was 1175 minus hypothesized value, which was 0.102, divided by our standard error of the population proportion, which is 0.015. And this is equal to 1.02. And now we can use the z distribution to find the probability of getting a z stat that is as extreme as this. So we go to jump, and then we will make sure that we check the right tail test, and we type in our test statistic, which is 1.02, and we get the probability value or p-value of 0.1539. So we'll just make a note of this. Our p-value is 0.1539. And our alpha, or level of significance, in the problem was 0.05. So our p-value is more than our level of significance. What this tells us is that there is a 0.1539 probability that our sample is coming from a population where the null is true. So, and it is above our level of significance of 0.05, so we fail to reject the null. So we can conclude that we do not have evidence that the membership has increased beyond what it was in 2018. So we fail to reject our null.